Okay, this is section 2 of chapter 5 in trigonometry. Again, I'm David Dipple from Lone Star College, Montgomery. In section 2, we're looking at the distributive property, and is sine of 30 plus sine of 30 equals sine of 60? Can you just add two angles and leave the sine function? Okay, let's see if that works. Sine of 30 is 1/2 plus a half, and the sine of 60 is square root of 3 over 2. That doesn't work. So you can't just add the angles. We could try it with 45. Cosine of 45 is 2 over 2, and cosine of 90 is 0. You can't just add the angles and cosine work. Now, but there is a formula for sine for adding two angles, and that is sine of the first, cosine of the second, plus cosine of the first, sine of the second. If you're subtracting, it's sine cosine minus cosine sine. And if there's a plus in parentheses, there's a plus on the right side. That's what we are working with. So suppose you want sine of 30 degrees plus 45 degrees. It's going to be sine of 30 cosine of 45 plus, because you keep the plus, cosine of 30 sine of 45. You take these two angles and it's sine cosine cosine sine. Okay, then you convert these. Sine of 30 cosine of 45, that's 1/2 square root of 2 over 2, square root of 3 over 2, square root of 2 over 2. When you put these together, that's the square root of 2 plus the square root of 6 all over 4. Okay, another example. Suppose you have sine of 60 minus 45. Again, it's going to be sine, cosine, and then cosine and sine. So it's going to be sine of the first one, 60, cosine of the second one, 45. Minus, because we have a minus in the middle, cosine of 60, sine of 45. Then you convert these. Sine of 60 is square root of 3 over 2. Cosine is square root of 2 over 2. Cosine of 60 is 1/2. Sine of 45 is 2 over 2. When you multiply these, you get square root of 6 minus the square root of 2. And the bottoms are both 4. So that's what works with sine. Okay, if you try cosine, same kind of thing. It's just a different pattern. With cosine, it's cosine of the first, cosine of the second, minus, if you have a plus, sine, sine. If you have a minus, it's cosine, cosine, plus sine, sine. So the trick with cosine is opposites. If in the parentheses you have a plus, between the two pairs there will be a minus. That's opposites. Okay, doing some examples. If you have cosine of 30 plus 45, if you look at this pattern, it's cosine, cosine, opposite, sine, sine. So it's going to be cosine 30, cosine 45, plus turns into minus, sine of 30, sine 45. Okay, the cosine of 30 and the cosine of 45 is 3 over 2, 2 over 2. Sine of 30 is 1/2. Sine of 45 is 2 over 2. So you get 6 minus 2 over 4, and tops have radicals in them. Okay, another example of cosine. Okay, it's going to be cosine of 60, cosine of 45, plus, this time, again, cosine is opposite, sine and sine. So it's cosine of 60, cosine of 45, minus turns into plus, sine of 60, sine of 45. Okay, you convert these using the circle numbers that we need to memorize. Okay, cosine of 60 is 1/2, cosine of 45 is 2 over 2. Sine of 60 is 3 over 2, sine of 45 is 2 over 2. The top turns is square root of 2, square root of 6, over 4, and there's a plus in between the two numerator. Now, the rule for tangent is if you're adding the angles, it's tan of the first one plus tan of the second one over 1 minus tangent of the first one, tangent of the second one, multiplied. So the top is plus and the bottom is minus. Okay, the plus goes to the top, opposite goes to the bottom. And if it's minus, the minus is on the top and the plus is on the bottom. Okay, you copy the sign, and on the bottom is opposite. Okay, suppose you have angle A in quadrant 1, where sine is 3/5. Angle B is in quadrant 3, where cosine is negative 5/13. Suppose you want to find tangent of A plus B. Okay, tangent of A, if you have 3/5, if you draw a triangle, tangent is going to be 3/4. You'll need to draw a triangle to find that. And tangent of B, if B is negative 5/13 in the third quadrant, tangent is going to be positive 12/5. Again, you need to draw a triangle. I can't do that very well on the PowerPoint. So draw a triangle in the third quadrant, put angle B, negative 5 is cosine adjacent, and 13 is a hypotenuse, so it's 12 is opposite, so it's 5/12. Which would be 12/5. Okay, now given this information, we can look at this fraction up here. Get tangent A, tangent B. So tangent of A is 3/4. Tangent of B is 12/5. 1 minus, and you multiply through together. So it's 3/4, 12/5. 1 minus 3/4, 12/5. Now to clean these up, I multiply by 4 and 5, because that's my common denominator. Multiply this by 20, this by 20, that by 20, and that by 20. And when you do that, 20 divided by 4 is 5 times 3 is 15. 4 times 12 is 48. 20 times 1 is 20. 20 cancels. 3 times 12 is 36. Then you can clean this up, and you will get 15 plus 48 is 63, and again I put the negative on the top as I usually do, and then 36 from 20 is 16. You could put that 63 over negative 16, that would work also. So in section 2 of chapter 5, we have sine, cosine, and tangent of adding angles together, and you just follow the pattern.